So, welcome everyone. Thanks for taking your time to attend to our driver configuration on InduSoft Web Studio webinar, October 2011. Really appreciate your participation. You'll be able to send questions on the Q&A chart here on the side. I'm gonna answer them, as we move forward. I'm gonna go take a look on the questions that at the end I hope I will have time enough to talk about all the questions that I may have received. Today on this webinar, my name is Andre Bastos. I'm the VP of Quality Assurance here at InduSoft, and I'm gonna be covering a quick company overview. Why do we have communication drivers and how those drivers are going to get the data out of the controller devices, what kind of data we exchange, what's the language that we speak, that's the concept of the communication protocols, and then we're going to start configuring some of our communication drivers. If there's any specific communication driver you guys would like to see, send a message. I'm gonna go and check. I have in mind right now, I'm gonna look on the Allen Bradley driver for communicating with control logics. I'm gonna be looking on the Siemens communication with the S7 300 400 series, and I have here also already a couple of other PLCs, so you guys are more than welcome to send your suggestions. If I have that handy here, I'll be able to cover that as well. Okay, all right, so a brief company overview. InduSoft was established in 1997 here in the United States, and we were the very first company to have a complete full solution that would run on Windows CE. And that was back, 1997, 1998. We were the very first one to provide a complete CE solution with web capabilities, and not only CE but also on Windows NT and 2000 that came right after that, with XML integration on the HMI and the SCADA package. And we do have also a patent for connectivity with any relational database, even for Windows CE devices, which means if you have a Windows CE HMI, you can connect to SQL Server, Oracle, or any other relational database using our gateway, our patent gateway for databases. Here are some of our certifications. We are OPC Foundation member since 1997, 98. We are always tested. We are Motorola certified, AT&T certified, and we are also one ISO 9001 company with the version 2008. And we've been winning a lot of awards on the latest years. It starts, all the way back to 2005 when we won the Frost & Sullivan company as entrepreneurial company award, and then we got Control Engineering Magazine Engineers Choice Awards on 2010 and 2011, and then we got that Frost & Sullivan again on 2010, as a Product Differentiation Excellence Award, as well as Customer Value Enhanced Award. So I really thank you guys, because a lot of these awards that we won, you guys were responsible for that. Some of you guys voted on the controls engineering, on the Frost & Sullivan, and because you guys use our product and keep the product evolving, I really appreciate your help on getting all this. The company is headquartered in the city of Austin, state of Texas, in the United States. We do have also 2 offices in Brazil, one in São Paulo and one in Campinas. It's about 60 miles away from São Paulo on the west side, and one office in Waldorf, Germany, right beside Heidelberg. That city is also the city where SAP has its headquarters as well. And you have a chain of distributors all over the world. You can name the country, as you can see there. You can find probably the country that you're looking for there, and we're still growing, signing new distributors. Every week, every month, we have new people coming aboard. So now, starting the technical part of our webinar, the need for the communication drivers. So why are we talking about the communication drivers? So I'm going to start with an example. So let's suppose we have an industrial furnace, and that furnace is going to need to generate heat. So we're gonna use gas burning furnace in our example. That's gonna generate a flare. That flare is gonna generate the heat. So not to make it completely detailed, we're gonna just put that the flare will be controlled to reach the temperature that we want it to be. So for you to know the temperature, you're gonna need to have some kind of sensor to send, to know what the temperature is, and you're gonna need somehow to control the gas valve that's gonna send the gas to the flare and keep the oven on the furnace on the temperature that you really want. So in order to know the temperature, we can put there some type of sensor, for example a thermocouple inside the furnace. That sensor is going to translate heat into current, into electric current, usually around a few milliamps, between 4 and 20 milliamps. So that thermocouple is going to do what with that information? It's going to send to a controller. At the same token, how is the valve going to know how much gas it should be dispensing on the flare? So the controller is going to be sending electronic signal. Again, it's a current around on the order of milliamps. That's going to tell the valve to open more and less, and according to the opening of the valve, you're gonna have more gas, and because of that, we're gonna have the correct heat, and the furnace is gonna be warm enough the way we want it to. So what we need to have is a controller, a process controller, such as a PAC, which is a programmable automation controller, or a PLC, programmable logical controllers, or those single and multi-loop controllers. That will be the one with the logic to control this valve according to the temperature that it receives from the sensors. So the thermocouple is going to translate the temperature into electric signals, and that will be converted in one of these controller modules from the analog electronic signal into digital. So the controller can then process that information, generate a value to open the valve, and then translate that value from the digital information that we have into actual electronic signal that will be sent to the valve, and the valve is going to have its servo that's going to move to open and close the valve according to the information that we sent to it. So then, knowing the actual temperature, you can also control how much more gas you have to put in there. So right now we're talking about field variables like the temperature and the gas position, sending electronic signals into the controllers. All right, but all right, how do I tell the furnace that that's the temperature that I want that flare to be? So when you have, for example, a microwave oven in your house, you're gonna enter the power that you want and how many minutes you have. So you have there your keyboard, right? So you have that keypad, you're gonna enter the information, hit start. So as you enter that information, that's the interface between you, the human being, and the machine or the appliance. And as you enter the information, you're passing this information to the controller, to the microcontroller inside the microwave oven, and that's when the microwave oven is going to start its cycle. So how can, on the industrial process, we make the controller know what's the set point of the temperature that I want? What's the temperature that I want inside the oven? So we need to have some type of interface on the controller for that to happen. Okay? So the controllers are not black boxes. I would say that 99% of them, they do have a way to communicate with the outside world. And that all starts with a physical communication port. You can have one or more than that. And inside the PLC itself, you're going to have one I/O image table, which means you're going to have the area that can communicate with the outside world. That's going to tell what the values are inside this controller. And finally, the capability of transmitting this data from the I/O image and to the I/O image through that communication port. Okay? So if you look here on these screenshots, you can have an idea that the PLC is here and has the I/O memory. That's the one that's going to be communicating with the outside world, and the PLC is going first to refresh this I/O memory, execute the program, and then refresh the output again. So it reads the I/O memory, execute the program, and refresh the I/O memory. And then the I/O memory will be made available through the communication ports to the outside world. So since those controllers are able to exchange data, it's going to be through one of these human-machine interfaces that you're going to send to interact with your process, to send, in our example, the temperature set point to your furnace. Okay? And the specific part that's gonna be taking care of sending this data out, of reading this data from the PLC, or more precisely, communicating through the communication channel with the controller, with the process controller, is the part of the software called the communication driver. Okay? So, the communication drivers on InduSoft Web Studio. Here is a brief architecture of our product, InduSoft Web Studio, and where the communication driver comes into play. So we're going to start here on the right part, where you have the process controller, and it has a communication channel, any communication port, and this communication channel is going to exchange data with the InduSoft Web Studio product, more precisely with the task called communication driver. So the way the Web Studio works is it has a central text database that ties up all the other tasks, and by task I mean, for example, we're capable of generating alarm messages, historical trend files, and drawing curves from these historical trend files. We are able to access relational databases, to manage recipes, generate reports. So all those tasks are part of the InduSoft Web Studio core process. And the visualization part for the local runtime is done by the local viewer. The local viewer is a separated process that exchanges data with the core process through TCP/IP. And in parallel, we have also the option to have remote viewers, only the viewer module remotely exchanging data through TCP/IP with the core process, as well as the web thin clients running on Internet Explorer. Okay? So, when I show this architecture, you can see that if I have a button on my screen, let's say to start the process, so I click on that button and that starts, it sends something on the PLC, you're going to have the button here on the local viewer, for example, that you push the button, we send the data to the core process, it reaches the text database, and the text database is going to distribute that information into the communication driver that will be the responsible to sending this data to the process controller through the communication channel. And then to show the temperature here on the local viewer, the driver is going to go through the communication channel, acquire the data from the process controller, send it to the text database, and through TCP/IP, the text database is going to send this data out to the local viewer, to the remote secure viewer, and web thin clients. So the first thing is, how will the drivers get the data from the PLC? This part is really important for you to understand later how you can improve the driver performance, improve the driver reliability. So it's important to understand these two layers of communication, the physical layer and the logical layer, and how they can affect the communication with the field devices. So talking about the physical layer, you can split that in two different categories, where the first category is going to be the drivers that use standard Windows resources. And by that I mean the physical channel are the common Windows channel. Then you have, for instance, the Ethernet port. Every computer nowadays have at least one, if not more than one, Ethernet port. And most of industrial computers, they still have serial communication channels. Those are the DB9 or DB15. Well, 15 is hard, but DB25 connectors on the PCs. Usually, most of them, and on the past, all the PCs, they used to have that as well. They would communicate through the serial channel on the default recommended standard RS-232. The RS-232 that goes on the COM port, it sends data through voltage where you have -12 and +12 volts, where -12 is 0, +12 is 1, and that's how you're going to send your bits and bytes to the other side. It's going to be through voltage. The RS-422 or 485, they are pretty similar. Those, no, they gonna use current, and you're gonna discuss the difference between them on the next slide. And finally, nowadays, every single PC has a USB port as well. Okay, so these two are default Windows ports, the serial communication and the Ethernet. The RS-422 or 485 is not that common on regular PCs, but most of industrial PLCs, you'll be able to find this port as well. And by that, I mean, if you buy one of these PCs, you don't need to install any other piece of software or piece of hardware to talk to the drivers that communicate serial and Ethernet. Okay, the second category of physical layer is when we use a third-party API. That we're gonna have to install a piece of hardware on my PC or on my HMI to communicate with buses that are not the original ones for Windows. More precise, the buses that are specific for industrial automation. Of course, you have also for building automation, but in this case here, I got some of them that are more used on the industrial automation, such as Profibus, ControlNet, Interbus, and you have in all type of communication as well, the CAN bus, that can be divided on CAN Open, DeviceNet, and several other flavors. But you have a specific bus for CAN. It's not something that you have on your PC. Same thing for Profibus, DeviceNet, etc. So if you want to use any of these networks here, you're gonna have to have a card on your PLC, on your PC, and that card is going to have a device driver and also one API to access that device driver at one end, and allows us to write a driver to access that API. Okay, so we're gonna go into more details about this two on the next slides. So talking about the serial communication, so when you talk about RS-232, or when you talk about serial communication at all, we're talking about the physical port is going to be used specifically for that type of communication. So I'm gonna use my COM1 only to talk to my PLCs. I cannot use the COM1 to do anything else. We are going to open on that specific baud rate, on that specific parity, on those specific communication parameters, and then exchange data with whoever is on the other side. Using RS-232, you can have only the communication with one device on the other side. So it's gonna have the PC at one end, and you're gonna have the PLC or any other controller on the other end. And since we're talking about voltage, you can have some resistance on the cable. You're gonna lose some of the voltage from one end to the other end. So it's not recommended for long distances. The maximum that I recommend is 100 feet or around 30 meters. That'd be the max for RS-232. And of course, you may be subject to some interference, so you need to isolate the cable pretty well for talking RS-232. So for longer distances, and if you want to have multi-drop capabilities, then you should use RS-422/RS-485. The main difference for me as a user, not as a hardware manufacturer, between these two is that RS-485 is only 2 wires, RS-422 is 4 wires. Other than that, a hardware manufacturer would be able to explain you better why exactly you have this number of wires. But the main advantage of this second architecture is that you can have way longer distances. You're not You're not limited to only 100 feet. You can go way more than that. And you can have multi-drop. So that means you can have several PLCs on the same RS-485 network. And you can communicate with all of them. And just keep in mind this, even though you can communicate with all of them, you can only communicate with one of them at a time. So if I have on this architecture 4 PLCs, my HMI is going to first communicate with one of these PLCs. Once the messages here are done, I'm going to go to the second PLC, third, fourth, and only finishing the last PLC. That's when I'm going to start reading the data from the first controller again. Okay, that's the concept of multi-drop when you use serial communications. And then nowadays you have lots of controllers with Ethernet capabilities. And as I started, if you compare the baud rate of an Ethernet connection with the baud rate of a serial connection, well, the lowest Ethernet that you have is 10 megabits per second, while the fastest you're gonna have on serial is, you know, around what, 115 megabits per second, so it's already 10 times faster. But most of Ethernet nowadays, you have 100 megabits per second and, you know, even 1 gigabit per second. So that already gives you one idea of how much more data you can exchange when you go through an Ethernet channel. And then on the Ethernet, you can have the same physical port doing several different things. You're not limited to only communicating with the PLC. You're probably used to use your computer to read your emails. At the same computer, you can go and access your web browser, and you can FTP to a remote website. They all use what? They all use our Ethernet port to do that, even your wireless Ethernet port. So the physical port can be used to several different things, differently than the serial. And one of these things that you can do is to talk to a PLC. So usually you go from your HMI into a switch hub, or, you know, any type of this kind of hubs, and then from them you go to the PLC that you want. So it's really important that the PLC and the protocol in the PLC supports some addressing method that, you know, can allow you from this HMI to go to a specific PLC. Let's say you go from HMI A into the PLC 1, you're gonna have to address that. But you can go, if you're on the network, you can address any PLC from any of these HMIs. Okay? And finally, we get to the physical layer that is not one of the default Windows resources. It's not the default serial or Ethernet. Those are the specific automation buses. And those guys require specific cards on your PC. And how you're going to connect these cards could be through USB, could be through PCI board, or, you know, any of this interface, PC104, things like that. And that's what you need when you want to have your PC communicating, for example, through Profibus, ControlNet, Interbus, CAN, the very well-known Alan Bradley, DH Plus, you know, an old network from Alan Bradley, but still out there because there's still a lot of PLC 5s and Slick 500 that speak DH Plus, speak DH 485, and Modbus Plus with Modicon, Controller Link with Almrom. So if you want to be in any of these networks here, you're gonna need to have a card on your PC, and as you put the card, you're gonna install a device driver so Windows can access these ports. And those hardware manufacturers, they also provide one API that we are going to use to write the driver. Since I cannot access directly the board the way we can do when we are doing serial or Ethernet, we're gonna go and access those specific APIs and write the drivers with those specific APIs. That's the case that we have, for example, to our CAN driver and to our Husher drivers, you know, for Profibus, DP Master, DB Slave, ControlNet, DeviceNet, and the driver that we have also for the 85 boards on the Modbus Plus. Could be serial, could be USB or PCI. Okay. So since I'm here, let me just quickly read one of the questions here. So we got a question asking, are you going to cover how to configure the drivers? Yes, we're gonna configure several different drivers. Let me see the other question that I have here. Okay, that's the only question so far. I get another question asking about the multi-drop on RS485. That's a good question. Like, you have some data freezing when you have one of the controllers not working properly on a RS485. So, if you look back here, so the question is, let's say that I'm talking to these 4 PLCs, and then let's say that this PLC here is down. So I'm gonna ask for this, get data. Ask for this, get data. And when I'm going to ask this one here, it will not respond. So we are going to time out. So you're gonna ask, wait, and then you're going to time out and then go to the next one. So when you have a multi-drop architecture like this one, and now at least one of the devices is down, I highly recommend disabling the communication with the one that is down until you figure out what's wrong, because this is going to slow down everything else, because the communication is synchronous. So it goes here, here, and then stops, and then goes here, 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 then stops here because of the timeout. Okay, so you're gonna see that you can control the driver to disable the communication. So let's say that you're having bad communications, you can disable that to see what's going on with that, and once you figure that out, you can re-enable the communication with that specific device. Okay, and then finally we get to the logical layer of the driver. So through that physical channel, we are going to exchange data, and but I need to know what type of bytes I'm going to send to the PLC, and how am I going to process the bytes that the PLC sends me back. So that's almost like a language. Okay, and that's what we call the communication protocol. So the communication protocols that we use in 90% of the cases is based on the master and slave concept, where the master is the one that initiates the communication, and the slave is the one that just sits idle listening for master requests and then replies back as the master sends the first message. Okay, so in a communication frame like this, usually you have the master preparing the message with some type of header that would include, for example, the device address, the function code. That would be, let's say I want to read coils, I want to read registers, and then here we put the bytes that what we are going to send. Like I want to read from the register 1 to the register 100, for example. And finally, one error check. The error check is a calculation that we do using all the bytes to check for the message consistency. So we send that to the slave side. The slave side receives that message, process that, and then replies back saying, oh, this is my address, that's the function code, here's the data that you requested, and it's gonna check it's gonna get the error check, calculate, receive all the bytes, calculate that, and see if the error check calculated on the slave side is the same as the one on the master side. If everything is fine, then the message means that's a good message, we have a good communication. The message transmitted by the master is what we call the TX messages. So if any of you guys already configure one InduSoft driver and you needed to debug it, you probably have seen in our debugging tools the TX messages. So the message transmitted by our drivers. And on the other hand, we have the replies from the slave. Usually comes with a header as well, saying, oh, I'm the slave replying to this request of the master, and then the message is going to have the data that we requested, and finally the error check calculation as well. The message that we receive from the slave is what we call the RX messages. Okay? So, some factors that really impact on the driver communication performance. The message size is defined by the protocol itself. So I cannot send to the PLC a message that the PLC will not be able to respond to me. And who defines that is the protocol that is used to communicate with that PLC, or the protocol that that PLC supports. For example, if I'm talking Modbus and my PLC supports only 8 registers per request, if I request 11 registers, the PLC is going to fail. You're gonna send me a reply saying, no, I cannot reply that to you. Okay? Mainly on the serial communications, you have smaller messages. For example, we have a Mitsubishi FX2 PLC. They support only 32 registers per message. If I request anything other than that, the PLC replies me with a NAC, non-acknowledgement, and doesn't give me any data. Other devices support 64 words. You even have Modbus serial devices supporting up to 125 words on the same message. So, depending on how much data you want to exchange with the PLC, you're going to have multiple messages, because you will not be able to fit all the messages on just, all the data that you want in just one message. All right? So that's why I highly recommend in your programming your PLC to think about the HMI as well, because the less messages that we gonna exchange with the PLC, that means that I'm gonna have faster communication. So instead of having one register on the, let's say, on the register 1, and then the register 100, and then on the register 1000, those guys, because of the message size that we can receive, you're gonna need to send one request for each one of these addresses. When, if you put them all together on the register 1, 2, and 3, we can get all this information from the same message. Okay? And then we have the specific case where it goes into the programmable automation controllers, and more precisely on the Allen Bradley control logics that is widely used out there. Those PLCs, they communicate using tag values, not exactly memory positions. So here you guys can see the RS Logix 5000. You can see a database from the RS Logix. So that's the control logics PLC that I'm connecting to right now. So here are the tag names inside the PLC. To communicate with those tag names, I actually need to send those tag names on my message. And this protocol has a limitation of only 544 bytes per message, and that includes my header, includes my error check, everything. So if you have several tag names and long tag names, they're gonna pretty much fill one message, with sometimes 11, 12 tags. So you're gonna need more messages to get the data from all these tags here. And that's not a limitation of the driver. This is actually a limitation of the protocol, the CIP protocol. Okay? And here's the first suggestion that I have for improving the communication with this type of PLC, which is use arrays. Even if you have to create aliases to your tags, that's going to improve the communication a lot. And why is that? If I talk to the AL from 0 to 32, my message that I'm going to send to the PLC is going to be, I want to talk to the AL tag from the position 0 to the position 24. And that's it. That's going to be my message. So it's going to be way shorter than if I send every single tag name on the message, like as I will do here. So can you imagine having only, let's say, 15 Boolean tags, only because the tag names are too long? So if you are a control logics user, I strongly recommend you, okay, you can keep your tag names the way it is, but create one array and create aliases for these array positions to use this array on the communication with the HMI, with our drivers. Okay? So here's our hint. Use arrays. Okay? And finally, we get the drivers that we use specific APIs from the manufacturers. That's the case, for example, to the back of TwinCAT. We don't talk to any back of PLC specifically. The ADS, which is the library provided by Backoff, is the one that talks to their PLCs. Doesn't matter if it's a soft PLC running on your PC, or if it's running on one of their Windows CE devices, or the proprietary hardware like the BC9000, BX9000. The ADS from Backoff is the one that's going to go to the PLC, and our driver, TwinCAT driver, is going to go and talk to the ADS. So you go driver to the ADS goes to the PLC. Okay. In a similar token, we have also the Almrom driver that goes through the FINS or SysMac gateway. we talk to the gateway, and then the gateway goes to the network. It doesn't matter if it's their Ethernet IP, their device net, their controller link network. For us, we are just talking to the fins or to the SysMac gateway. Okay, and there are other similar examples like the Modbus Plus, that we talk to the CyberLogic and APIs, and the CyberLogic goes to the PLC. We have the CodeSys based PLCs like the Wago or the Eaton Moller PLCs. They also run CodeSys, so we go through the API from PLC handler. So some specific devices, we must have the API to write the driver. That's why there are some devices out there that we don't have the drivers for them, because we simply don't have those APIs to write the driver to them. Okay? And that's the important part. The performance of this kind of driver depends 99% of the performance of their APIs. If we call it API function and it takes like 5 seconds to reply, there's nothing that the driver can do to improve that. For example, on the ADS from backoff, as we ask any information, we get that in 20 milliseconds or even less. Same thing with Armor, we get the data about like 50 to 60 milliseconds. That's how long it takes to exchange data with these two guys here. But there are other devices that it takes longer for the APIs to process the request and reply to our driver. Okay, let me see if there are any specific questions about that right now. Okay, so getting now into more precisely on the Ethernet drivers. So when it talked about the serial drivers, when it said that the RS485, we can have multi-drop, but we go to each one of these guys at a time, to each one of the PLCs at a time, that's a limitation of doing a serial communication. But when you do Ethernet, you can have one Ethernet device having several connections at the same time. That means I can have one PLC up here. I can have one PLC up here. Come on. That can talk to any of these HMIs. So taking the PLC A here, I'm gonna have HMI 1, 2, and 3 talking to this PLC at the same time. That means it supports at least 3 connections, right? All at the same time, all in parallel. Okay, what if I make one of these HMIs open parallel sessions to talk to the same PLC? For the PLC, it's gonna be exactly the same thing. You're having just multiple connections. So doing that, you can improve the communication, because you can have the same driver acting as if it was 4, 5, or 8 different drivers at the same time talking to the PLC. And that's on the advanced settings for the communication driver. Any driver, Ethernet driver, is going to have that. You can configure the simultaneous requests. So you can configure how many simultaneous requests you're going to have per station. So how many are going to go on the same PLC, and a total for the driver. So let's say that we are going through Ethernet communicating with 4 different PLCs. So I can have 4 separated connections for each PLC, totalizing 16 on total. 4 PLCs times 4, I have 16 connections on this specific driver. So I'm opening here 16 independent instances of the driver during the runtime in memory. The user doesn't have to see that. So when you're configuring Ethernet communications, it's strongly recommended to configure some of these guys here. Okay, I do not strongly recommend that on Windows CE, because that really uses a lot of memory, and on Windows CE usually you have limitations on the memory that you can use. Okay, but if you are on Windows XP, if you are on a PC, you should be fine to open as many parallel connections as you wish. So finally, configure the drivers on InduSoft Web Studio. So I'm gonna move here to InduSoft Web Studio, and let me open here. We're gonna create a new project using InduSoft Web Studio. So I'm gonna create here the webinar driver config. So I'm creating here the project. So it's a blank, completely new project. So if I have one screen, and I'm gonna have one button on that screen that's going to send data to the PLC. So as I push this button, I'm gonna send a command to, let's say, toggle a tag on my PLC. So I'm gonna put here my PLC tag. Okay, so when I click on this button, I'm gonna toggle the PLC tag. This tag doesn't exist, I'm gonna create that as a Boolean tag. Okay, so as I push this button, I'm going to go and send the value to the PLC. So how do I connect this tag here with my PLC? So we're gonna go on the drivers part of InduSoft Web Studio. Okay, so on the drivers, that's when I create the association between our tags and the PLC. I'm going to insert here two drivers as a starting point. The Allen Bradley Control Logics driver, that's what we call ABCIP driver. And I'm going to also connect to a Siemens PLC using Ethernet to a S7300 that we have here in the office. Okay, so as you can see on Web Studio, you can have different drivers on the same project with no problem. And as always, the drivers are part of the product, but they are still dynamic. So if you have to upgrade the driver for a newer version, you don't need to upgrade your entire product. You can go to our website, download the latest driver versions. So let's start, for example, with the Allen Bradley driver, the Control Logics. So you can have two types of driver sheets. You can have what we call the main driver sheets. You can have one main driver sheet per driver. Okay, the layout is pretty much the same. Doesn't matter if you're on the Allen Bradley driver or on the Siemens driver. You can see the layout of the worksheet is the same. And here you associate the InduSoft tag with the PLC address. So for example, I'm going to put here the tag that we have created. I'm going to insert the tag. Our project tag that we created, the PLC tag, is going to go to my Allen Bradley PLC that I have here. So where is this PLC? Okay, this PLC is actually here on the Ethernet. I'm talking to this 74 PLC here on the backplane, and the CPU is on the slot number 1. So that's my IP address, and that's where the CPU is. These two information are important for configuring the driver. So here on the station for the Allen Bradley driver, I've got to enter the IP address, colon, the slot position of the CPU. Alright? And on the I/O address, I gotta enter two things: the type of the tag that I want to communicate with, and the name of the tag. So, for example, if I want to send a command to this Boolean tag called ABC here, I go here on Web Studio and say I'm going to communicate with the bool tag ABC. Here say if I'm going to read, write, or both. And if I'm going to do that only on the screen, or I'm going to do that always, or I'm going to let the software decide if I'm going to do always or on screen. Okay, so getting this quick example here, if I from here call the runtime on Web Studio, and I'm going to click on this button here, if I look on the PLC, and I look at the value for the tag ABC, I have the value 1. If I click again, use the runtime, I'm toggling the tag. So when I look on the PLC, now I have 0. Okay, so it's using the driver that we associate the values to the tag. But I don't need to have entire application configured to start debugging my driver, to start configuring my driver. You can take advantage of these two tools that we have down here, the database spy and the output window. Okay, on the output window, if I right click select settings, I can choose what type of information I'm gonna read or I'm going to print out here from my driver communication. So if I check this first box, I'm gonna send messages here telling me the status of my read command from the PLC. Same thing about the second one. I'm gonna have here the status of my write commands. So if you look up here, I have OK communications for reading, and when I wrote, I have OK communication when I wrote to the PLC. Okay, and to check the tag value, I can use our database spy here. So here I can have the tag values. I can force values to the tag. So while I'm configuring the driver, I don't need to have everything in place on the screen. I can use these two tools here and debug pretty much everything that I need. Okay? So using this driver, the ABCIP driver, if I have other Boolean tags, for example, we have here this tag called any blast tunnel for OIT. If I want to talk to this guy, I'm gonna have to put the type bool and then the tag name. Going to the same PLC here, and I'm gonna create here another Web Studio tag that could be a Boolean tag. So now I have on the same message, I'm gonna be talking to these two tags here. So if I want to debug the driver only, we can go here on the Home tab under Tasks and start the driver only. So now the driver is running, and I can debug and see that I do have the value 1 on this PLC tag here. If I want to write to it, I'm going to write 0. When I look on the PLC, now the tag changed to 0. That means my communication is happening. Alright, now I'm going to look on this other tag that is a different type. There's an integer tag. I have the value 567. So if I want to talk to this guy, I'm going to put int, colon, and then the tag name. Okay, so I'm going to create here a tag name with the same name in there. I didn't even need to stop the driver. I just saved the worksheet using Ctrl S, and now my communication is happening also with the integers. So if you look here on the output window, you're gonna see that you have now, let me pause, messages related to the Boolean tags and a separated message to the integer tags. This means that I'm already sending to the PLC two messages, one for Booleans, one for integers. Okay, so what's the problem with that? As I put different types, I'm gonna have more messages. So let's say I want to talk to this array position here. This tag called array1 position 0, and that one double integer. So I'm gonna put here double int going to this tag on this IP here. So I'm talking now to this tag here. You can see it's updating now. And on my output window, if I unpause it, that means that I already have 3 groups talking to the PLC. One for the booleans, one for the double integers, one for the integers. So we're always going to have different groups for the different types with the control logics. And the more tag names, the longer the tag names are, we're gonna be filling up pretty quickly the message size. So if I look here on this database, in the beginning we have these tags here that I call a log real tag name. So if I want to communicate with all of this guys here, I'm probably going to have what, about 12 tags on that's going to be one group, and then I'm gonna have other 12 tags going to be a separate group. Why? Because on the message that I sent to the PLC, I must include the tag name of each one of these tags. Even though they're pretty similar, they're still separated independent tags. Okay? However, if instead of doing this, I create just one array tag, this here called a long array tag, a log real tag name array, and I pass here only this tag name, and I send how many of these guys I want on my message, I may have what, instead of 12, 120 of those on the same message. Okay, because what I send to the PLC is the tag name, initial position, and number of array position that I want to communicate with, and the PLC replies in back only with the data. So again, this is going to be way faster communication than if you're doing something like this here. This here, where each one of the tags has a different name. Okay? So, when we go to other driver, like the Siemens driver, you're not talking about tag names anymore. So on the Siemens, I'm gonna show a different PLC that I have, a different computer that I have here, where I have the Cymatic Manager. And on this Cymatic Manager, I'm going to look into some PLC variables. So for example, on this PLC that I have here, I'm going to see what value I have on the M byte 0. So I'm going to start reading. So here's the data. I'm going to change this format to decimal. Okay, so that's the data that we are getting on this specific byte. Or if I change that to word, here's the value that I have on the M word 0. So on the Siemens, we don't talk to the symbol name or to the tag name. We talk to the memory area. So here, using the PLC programming software, I'm going to put, for example, I have on the Siemens a DB1. If you're familiar with Siemens, you're going to see that I have, for example, here my DB1, the byte 1, it has the value 67. So if I not talk to these addresses using our Siemens driver, I will not put any tag name. I'm going to put those addresses on the driver. So let me go back to Web Studio. I go here on the Siemens, on the main driver sheet for the Siemens. So here I put the tag name that I want. For example, I'm going to create a tag called SAIF MW0. This tag doesn't exist. I'm going to create that as an integer. And I'm going to enter here the station field of that PLC. So the syntax for the Siemens communication is I need to know the PLC IP address, backplane number, as well as the slot number where the CPU is. So looking here on the Siemens, when I look on my S7 here, when I look on the hardware, I see that the CPU is on the slot number 2 on my backplane number 0. Okay? And the IP address is 10.168.23.90. So I go back on Web Studio, I configure the IP address 10.168.23.90 colon the position, the bus number, the backplane number, and the slot position for the CPU. So here I'm telling which PLC I'm going to communicate with. And finally, I put the I/O address. So I'm going to talk to the memory word 0. Okay? As I save this, if I look here on my database SPI, I'm now talking to this address as well. If I unpause, now on the output here, I see messages both related to the Siemens driver and to the Allen Bradley driver. To the Siemens, I only have one message at a time. If I want to talk also with, for example, the DB1, so here's my tag that I just created. I'm gonna go on the same PLC, but I'm talking to the DB1 on the byte number 1. So now I have that value 67 that we had before, and here on the output window I'm going to see that on the Siemens driver now I have both the DB1 and another message for the MW. okay? But if I want to talk to any other M, so I put here, for example, the M byte 20. I put here Saif M byte 20. The message is going to be the same. I'm going to get whatever value I have on the byte 20, which is 3. But I don't have a separated message for that because I'm still on the same block. So one for the dBs and one for the M's. All the M's, doesn't matter the format. If it's word, if it is double word, if it is byte, all the M's are going to fit on the same message. Okay? So for Siemens, my hint is that you use dBs as much as possible because you can fit a lot of dB positions on the same message. Okay? So the less number of dBs that you use, the better is going to be the communication. Don't say, oh, Andre said we should use dBs, so I'm going to use 100 different dBs on the Siemens. Not quite. Try to keep the number of dBs that's going to be used on the communication low. Let's say you're going to have 3 or 4 dBs and use all the positions of this dB. We can fit up to 1022 bytes for each dB communication. So the less number of the messages, the better the communication. Okay? So, in this two cases here, we configure the main driver sheet. So the main driver sheet is very simple to be configured. I put here my tag, and here I put which I/O address I'm going to communicate with. And of course I put the station where I'm going to reach the PLC. The main difference between the main driver sheet and the standard driver sheet, so I'm gonna go here on the Allen Bradley, I'm gonna insert a standard driver sheet. So the interface is similar but completely different. Here you have the station as one field here, while here was one cell. So, and also you have this new field here called header. So some of the differences between the main driver sheet and the standard driver sheet is that you're gonna have one standard driver sheet for each station, for each PLC they're gonna talk to. You're gonna have it talking to different PLCs, while here, yes, you can be talking to different PLCs on the same worksheet. But here you're gonna also have only one type of tag or one type of memory per worksheet as well. However, you can have as many standard driver sheets as you want. So I can create here one. We're gonna talk only to real tags, okay, on the PLC 10.168.23.74 slot 1, okay, and talking to which tag. Let me look here on the control logics. So I'm gonna talk to this tag up here called alog tag name 2. So I go here on my driver, and that's the tag that I'm gonna communicate with. So here I don't need to put the type anymore. I put the type only once here on my header. And here I'm gonna put my tag name. So it's going to be ABCIP SDS. So this tag doesn't exist. I just created this tag. Alright. So I save this worksheet. It's going to ask me to give it a number. I can give any number from 1 to 9,999. But right now, I'm still not talking to this tag yet. That's one of the differences. On the main driver sheet, as you're running the driver and you configure, we immediately start talking. You don't need to configure anything else. Here on the standard driver sheet, you must configure when you're going to communicate, when you're going to read, when you're going to write. This is good in one aspect, because on the main driver sheet, you are hard-coded on 600 milliseconds. You can change that. On our help file, we show how you can change that, but the entire worksheet is always going to read on the same rate. So if you change that to 200 milliseconds, you're going to read everything every 200 milliseconds. You cannot have, for example, your alarm tags being reading as fast as possible, but The temperature you're gonna read only every second. You cannot have that using main driver sheet. But you can have different standard driver sheets with different refresh rates. So, as an example, as we're going to read this tag here, we have two ways to configure that. I can read either using the field called read trigger. The read trigger, if I put a tag here, I'm going to put, for example, the tag seconds. Whenever this tag here changes the value, I'm going to read my entire worksheet. So if I, for example, I'm going to put here other tag that I'm creating now. And this is going to communicate with this PLC tag here. So right now I started reading these values. And if I enable here my log, I will see that I have the messages related to that group. The real tags, the group number 1. Okay? So I'm reading that every second because I've used that trigger. Alright, what's the fastest that I can read? What's the fastest trigger? Well, if you want to read something as fast as possible, instead of using the triggers, we should use this field here that means enable read when idle. Basically, it's enable read. I'm going to read as fast as possible. Idle means that I'm not writing anything, I'm not reading any specific message from the trigger, so I'm going to be reading as fast as possible. Here you can put a tag or you can put a value. Anything greater than 0 is going to enable this worksheet. So I put here, I'm going to save this guy. As I save, when I run, look, if I pause now, see how many times I'm reading comparing to the other groups. Because I'm reading as fast as possible. So if I enable here to insert the date and time, each one of these messages is going to have a timestamp. So as I see the timestamp, for example here, I see that the messages are taking what? Depending on the case, 70 milliseconds to get back from the PLC. Here it took only 30 milliseconds to get back from the PLC. So as you can see, it's going pretty fast because I enabled to read when idle. So I'm idle, I'm reading. Okay? And then on the standard driver sheets, you have the feedback information for each one of the driver sheets separately. So if I put here a tag, I'm going to call read completed. This tag is going to be toggling. So I'm going to create a boolean. Whenever I finish reading something, this tag is going to be toggling. So it toggles way faster than the database SPI is able to process. Okay? And we have also here the read status fields for each one of the driver sheets. This field gives you the feedback if the communication is good or not on an integer value. So if I put here the tag read status on the database SPI, 0 means the communication is good. If by any chance, let's say I'm gonna talk to the wrong PLC, then I receive an error. So any value different than 0 means I have a bad communication. And here's the message, error to establish the connection. I go back to a good IP address. Here I am talking again. The tag of the call is good and my read status is 0, which means the communication is going well. Okay? So to write, the way it works, you're going to control when you want to write as well, using the standard driver sheets. So if you put here a trigger, I'm going to create, for example, a write trigger. That can be any tag value. So I'm going to create that as a boolean. I'm going to just toggle this tag and put here. So right now, I'm constantly reading from the PLC. So I have these two tags with the value 4.5 and 2 on the PLC. If I try to write to these tags, the PLC is going to override it because, I'm reading. So if I, let's say, if I stop reading and then I'm gonna write values to these tags, I'm gonna write, for example, on this one I'm gonna write 8.8 and here I'm gonna write 7.7. Right now, if I look, I still don't have these values on my PLC. As soon as I use the read trigger and I trigger that value, poof, I wrote that to the PLC. So when I look here, I have the new values that I've just written. And we write all of them in just one shot. So the write trigger is recommended, for example, to send recipes, to send parameters, several parameters in just one shot to the PLC. Or I can enable this other option that can also be a tag or a value that whenever the tag changes, I'm gonna write to the PLC. So I don't have the trigger anymore. I'm gonna go here and write 5.5 and 4.4. I did not hit the trigger is still there. When I look on the PLC, I have the new values. So those are, I'm writing items whenever the tag changes, I write to the PLC if I enable this field here. Okay, so if I do something like this, I'm reading as fast as possible and I'm writing whenever anything changes. Alright, and I can have here the feedback that tells me when I finish writing something, and here the status, if the writing was okay or if I had a communication error when trying to write to the PLC. So depending on the sequence of commands that you may be doing on your process, you may want to make sure that you write one tag first before writing another one, so you can check that it's completed. When it is completed, check the status. If the status was fine, then you can move forward to the second command, something like this. On the main driver sheet, you also have the completed and the statuses, but this is generic to the entire worksheet and to all the groups. So let's say that the bool communications are good, but the integer communications are bad. So the status is gonna be switching between good and bad. So it's gonna be good where I have booleans, double integers, gonna have 0 on the tag that is here. But as I read integer and it fails, I'm gonna have a different value here. So it's gonna go from 0, 0 to minus 60, 0, 0, minus 60. So it's going to be toggling, and only by looking on the screen, you're not going to know exactly which one is having a bad communication. Okay, that's where you're going to come here and look on this output window to see who is having a bad communication. All right? So, using the Siemens driver, for example, you can also configure standard driver sheets. On the Siemens case, the way it works is you're gonna put one station as well, so it would be one station backplane slot, but you have to configure a header as well. When you configure the header, I say I'm gonna talk to only the M's, okay? It's starting on the M0. And here on the address, you're gonna configure one offset to this initial position. So here on the address, I'm gonna put, for example, I'm gonna talk to the word 0. And this is going to go to my standard driver sheet tag called MW0. So I created this tag, and as soon as I enable reading, I can start reading this tag here. I save the worksheet, and now I am communicating also with the Siemens, as you can see here. Alright? So this communication is way faster than the one that we had before. So if I want to talk here also to the word 120, they fit in just one message. Okay, so you should keep the values close within the block size. The block size is defined on the driver help. You're gonna see the block size for each one of the addresses type. Okay, so if I try to write now something, I'm gonna enable writing here. I'm gonna go to the word 120. I'm gonna write For example, 456 on the word 20. If I look here on my Siemens, and I'm gonna try to communicate with the memory word 120, as I put that in decimal, 456, the value that I wrote there. So they're reading this guy pretty fast, and we are writing and reading and writing this guy here as well. Okay, so these are some of the differences to use the standard driver sheets, where you have full control of your communication, and the main driver sheet, where it's easier to configure, but you're pretty much, you know, locked in the 600 millisecond rate. All right, and I'm gonna take that advantage here on the ABCIP driver, select settings, and then advanced, and here you're gonna see that you are able to configure the simultaneous requests. So I can open on this Allen Bradley driver. I'm gonna open, for example, I have only one PLC. I'm gonna open 4 different connections to that PLC, and the communication is going to happen in parallel. Since I have only 4 tags, that really doesn't make much sense. But if I were communicating with thousands of tags, you know, several tags, it's really worth opening this, multiple connections, several connections per PLC, and you're gonna do the communication in parallel. Otherwise, we're gonna be always communicating booleans first, integers, double integers, and then booleans, integers, double integers. If we open multiple connections, you're gonna be talking to all of them at the same time. You're gonna be sending a message to the PLC at the same time. Just keep in mind that each PLC has its own limitations of communications or connections. The Allen Bradleys, for example, they are able to handle sometimes 60, I guess 64 connections. But if you're using our driver called ABENI, for example, that driver communicates with the MicroLogix family, you know, SLIC family, using the 1756 ENI module. That module translates from Ethernet IP into serial, but it has only 6 connections. If you try any more than that, you'll not be able to connect to that module. So the number of simultaneous connections that you're going to use is going to be restricted to the number supported by the PLC. Okay, which usually, I know, Fanuc PLCs, Allen Bradley PLCs, is usually a pretty large number. Okay, so here's the hint on Allen Bradley: use arrays, keep the number of keep the tag name as short as possible, and use multiple connections. You're gonna have the best communication possible. If you use several tag names with long tag names, you're gonna need to send more message to the PLC, and that's gonna slow down your overall communication, because you're gonna need to go to each worksheet at a time. Even if you have multiple connections, you cannot have, let's say, 100 multiple connections if you have 100 worksheets. So you're gonna need to go to each one of the worksheets on that connection at a time, and then start the first one again. And when you're using a PLC that is based on memory, like the Siemens PLC, Omron PLC, then instead you should use the memories pretty close to each other. So program the PLC thinking about the HMI as well, at least on the communication part. Communicate with DBs, a less number of DBs as possible to the Siemens, and you're gonna have a real good communication. Okay? So, I got a question here, interesting one from Robert, asking, on the Allen Bradley SLIC, how do you connect directly to the memory address on the PLC? So, that would be a different driver. If we're talking to the SLICs, we have to the SLIC 505 and the PLC 5 a driver called ABTCP. So with this driver ABTCP, I'm gonna insert that here, and I'm gonna communicate. Let me see if I have that PLC available here. Well, I do have a PLC 5. I'm not sure I have 189. Yeah, I'm not sure I have here the one SLIC. I should have a SLIC Let me try something real quick here. Okay, it's pinging. So I have a remote SLIC. So I can, on my ABTCP driver, right click, select settings. Here I select which PLC family I'm going to communicate with. Okay, so since you asked specifically for the SLIC, I'm gonna keep here the SLIC 500. And then I open the main driver sheet. I enter here my tag name. For example, I'm gonna put here my I'm gonna create a tag name called AB TCP N7. Doesn't exist. I'm gonna create that as an integer. I'm gonna enter here my IP address. So here's where my PLC is, and I enter here the I/O address the same way as I do with most Allen Bradleys. So N7 colon 0, N7 colon 20, F8 colon 1, B3 colon 0 / 2. So that's the syntax. If you type something invalid, we validate that and we put something else. In this case, you're putting one R6. Okay? So if I'm gonna talk to all these addresses here on that PLC, I'm gonna put here other tag. I'm gonna call it N720. I'm gonna call here the F8, and this is going to be my B3 bit. So if I run this driver now that I just inserted, so I gotta start the drivers. Now I'm talking to these addresses as well, using the Allen Bradley. So those are basically the values that I have on that PLC right there. It's in a remote office. I don't have access using Earth Logics to that PLC. Not on these computers that I'm using here. Okay, so you pretty much put the address here. One interesting thing about the ABC IP driver is that using the backplane from a ControlLogix, you can have one DH Plus card that opens to other DH Plus networks. So I have, for example, a SLIC 500, 504, which doesn't have Ethernet, but it has DH Plus. So I'm going through my DH Plus network on the channel B, through the backplane, and then on the ControlLogix. So I could use the ABC IP driver. So I'm gonna go on the ABC IP driver here, and if I configure one station like this, PLC type, IP address, slot number where the DH Plus card is, where is that? The DH Plus card is on the slot number 2. Actually, first the backplane number 0, and then slot number 2, and then the channel number that I'm going to. The channel is channel B, and finally the PLC address, which is 1. And I'm going to talk to my N7 colon 0. Let me see if I have the good communication here. No, I have a bad communication because I put a wrong IP address, 10. Family. Should it be 1? Yes, that was the problem. So actually the backplane is number 1. That's right, backplane number 1. So I enter here family, backplane, IP actually, backplane, slot of the DH Plus card, channel, and address. If you look here on our links, channel B, address 1 is my SLIC, on the backplane 1 on this IP address. Okay, so yeah, we can do this type of thing as well, but only because I'm going first through the ControlLogix and then to the DH Plus network. If I talk directly Ethernet, I'm gonna go like this. If I not talk serial to one Allen Bradley PLC, then I would use our driver called ABKE, this one here. It's exactly the same as the ABTCP, but we go for the serial port. So instead of configuring the station, the IP address, you would configure the PLC slave number if you have multiple PLCs. Otherwise, it would be only one PLC. Okay. All right. I also have here other PLCs in our network. I have a TwinCAT PLC. The TwinCAT is a very interesting case because the TwinCAT, you talk to the variable names the same way as we do with the control logics. Okay, so here I have a TwinCAT running. So we go to the backoff API, and from the backoff API, so if I have here one project and I put our TwinCAT driver, we are going to associate our tags. So I'm going to create here a PLC tag to the TwinCAT variable name. So in this case here we have this variable called count that has the value 727 right now. So I go here and I put for global variables a dot and the variable name. So as I start my driver runtime, I'm now communicating with this tag on my TwinCAT. So I have here 727. If I'm gonna write to it, I'm gonna write, for example, 888. Boom. I wrote to this tag here on the TwinCAT. Okay, and my TwinCAT's running locally on the PC. So if I run locally, I don't need to put anything on the station. If I'm communicating with a remote TwinCAT, so I will need to know the router IP address. For example, I have here this AMS net ID. So that's what I would put on the station field. Gonna connect to that. Okay, so my local PLC has this AMS net ID, and I can have up to 4 different runtimes on the same PC. So doing this, I make sure that I'm talking to this PLC on the first runtime. Okay, so that's one case that I'm talking to variable names, but I don't even need to declare the type. We get that from the ADS communication directly from backoff. All right, so we have seen some Siemens with fixed addresses. We have seen some Allen Bradley where you have tag names. The last curiosity on Allen Bradley, if you have a program tag, for example, you have here a program called main program right here, where we have some tags on this main program that were declared here. We have, for example, this tag called BG mapping page, and that's inside the main program. So if I monitor this tag, right now I have the value 1111 inside main program. So to reach this tag using our ABCIP driver, I have to configure the type. So the type here is integer. Okay, so I go here on the driver and then I put integer, and then I gotta declare that this is a program tag. So I type program and then I put colon the name of the program dot the tag name. Okay, so if I put here, let's say local tag 1, this tag is going to have the value 1111 as well. Here we go, the same one that we have here on the PLC, and I can write it to I can write to it as well. I think I can, right? Let me see. Yes, here it is. Okay. While if you go on the TwinCAT and you have local variables as well, for example, I have here on the main program this variable called webxvar. It's local from my main program. All I have to do on InduSoft is put the program name dot the variable name, and I'm gonna be talking to it. So if I look here, there you go. I got the value 1, 2, 3, the same one that I have on the PLC. I can write something else in the PLC. When I look on Web Studio, here's my value. All right. So we're heading now to the end of our presentation. If you guys have any specific questions about any specific driver that you want to ask, or advantage and disadvantage of using standard driver sheet, main driver sheet, or using multiple connections, please feel free to go ahead and ask these questions right now. So I got an interesting question here from Mr. Cruz Castillo, asking what are the key points to check when you are using a serial to Ethernet gateways like MOXA. So the way the question that he's asking is more specifically when you're using a serial driver. So I'm gonna insert here, for example, another driver. I'm gonna put, for example, a Modbus driver. Okay, the Modbus serial driver. So for serial drivers, if I configure here the settings, I would configure which COM port I'm going to, the baud rate, all this type of things. And you would go here and configure the encapsulation for TCP/IP. Doing this, instead of going to the COM port, you're going to a serial to Ethernet converter. For example, he gave an example here from MOXA, and you'll have also from Advantech, ICP-DAS, and several other manufacturers. And you're going to configure those serial parameters actually on the converter, and from here you're going to go and access the IP address of the converter and the port number. And here you're going to have a status tag. So if the communication is failing by any chance, first thing to see is if this status tag has any value different than 0. You'll look on our help to see what error you're having with that, but always look on the output window that we display the messages of what is going wrong with the communication. The first thing to do is to try to ping this IP address here, try to telnet this port. If these two are fine, the communication should be fine as well. Okay, I got another question here from Robert. How do we set the tags for IP addresses? That's a very good question. So let's say that I don't want to have a fixed IP address here because I may want to use, I don't know, redundancy or things like this. Could I have a tag here instead of a fixed value? Definitely. So I'm going to use an example. I'm going to create here a guy called PLC station. I'm going to create this tag as a string. So whenever you put a tag between curly brackets on the station field, we're going to assume the value of this tag as the IP address. Okay, so I'm going to put here, everywhere here, and I'm going to put this PLC station tag first going to be blank. So as I say, if I start getting communication errors, because right now I don't have communication, so you're gonna see that we have a couple of error that says blank station. So that fails. So if I go ahead here and enter So the communication here for these tags, let me move to the first tab again. See, the communication is bad. The communication is bad because I'm not getting anything with this blank tag. So I'm gonna put here the correct station value. So now we're gonna start communicating again. Now you should start communicating again. It still sees as blank station. Is there a tag? And there, I have another question. Is there a tag editor? Yes, Robert, there's a tag editor if you go here on the global. I didn't cover that part only because I'm focusing on the driver, but here you have all the project tags. Where you see all the tags that you have created. You can create these tags as array, change their types, add more tags. Okay? So this is where you can create your tags. Alright? So let me go here and remove the mod view driver because that's gonna fail on my communication. So here is the station tag that we have created. The communication is good now, as you can see. I have the PLC station tag with the value, proper values. So here the tags, they have the proper values coming from the PLC. Okay, so I'm using this interface here, the database SPI, to load a value into my tag called PLC station. And then I'm using this PLC station between curly brackets on my station fields of my worksheet. So as I change this value here, I'm gonna put, for example, 0 here. I'm gonna start having communication errors. I put it good. I'm communicating well again. Okay? So I got one more question here about Modbus TCP IP. Ronald asked the question about Modbus TCP. We do have a driver called MOTCP here. That one is a native Modbus TCP. It's different than the encapsulation that I was showing before. The encapsulation that I was showing before is more if you want to try to have a serial to Ethernet converter. Usually you use that with RTUs, you know, radio communications, where the PLC doesn't have Ethernet capabilities, has serial only. So you put that converter going to the serial port on the PLC at one end and the Ethernet at the other end. For PLCs that have the Modbus capability, so Ethernet capabilities, you can use this driver called MOTCP. So I do have one PLC here that can speak MOTCP. I'm gonna create a tag real quick. Going to the register 40,001. So I'm gonna put the station, the IP address, .60, and the address. If I put 40,001, I never know how many zeros I would have. So I just put 4x. So that would be 40,001, 400,001. Just put 4, which is the type, x colon 1. So as I start the driver, I'm gonna see the value of this tag here. And I have a bad quality, mainly because I did not configure here two things: TCP/IP port number and slave address. Now I got values coming from that PLC. So depending on the PLC, the station field is going to have different syntaxes. So on the Siemens, I put IP address, backplane, and slot position. On Modbus, I have to have IP address, port number, TCP IP port number, which is configurable, but usually 502, and the slave address of my Modbus slave device. So here I'm talking to the 40,001. And then you can do 3x, 0x, 1x, format as floating point, all this type of stuff. Okay? So, I got a question here from Andy asking, the PLC max connections, is that stated on the InduSoft driver help file? Well, the max connections will not be specifically for drivers. Well, it can be specific for drivers. When the driver has a limitation, we put that on the driver specific help. Okay? So for instance, on the ABENI, we're gonna have a max of 6 connections. But we don't control. You can type any value that you want there. Okay? So I got an interesting question here from Bob asking, for control logics, is there any advantage to using the native control logics driver versus using the OPC through RS links? Well, communication-wise, I'm gonna be quite honest with you. Using our driver, we're talking to the tag names on the control logics PLC. All right. If you use the RS links and the OPC for the RS links, you're talking about Rockwell speaking with Rockwell, and then we're speaking OPC with the Rockwell. The main thing about that is that you will need to buy the OPC server for Rockwell, while the ABC IP driver is part of the product. As you buy the license for InduSoft Web Studio, you get all the drivers with that. Okay, only a couple of specific drivers you pay separately, but you know, you get more than 200 drivers with the license itself. And the Allen Bradley Control Logics is part of the license. You don't need to buy any extra. Okay, so it's part of the product. That would be the only difference, Bob, you know, with using RS links as OPC server. You don't need to buy any extra. Okay, I got another question here about the Modbus TCP. That's a good question. He's asking a question, if I have on the standard driver sheets, could be from any driver here, could be on Siemens or on the Modbus, I'm going to use the interface which is pretty much the same on the Siemens or on the Allen Bradley, about the right trigger here. So if I have a tag here on the right trigger, whenever this tag changes, I write the entire sheet. Okay, so if I do something like this, I put here a tag called second, that means that I'm gonna be writing to these tags every second. So you may think if that's really what you want to do or not, because if you use enable write on tag change, whenever you change the value, you write that specific tag that was changed to the PLC. So enable write on tag change writes only the tag that changed. Right trigger writes all the tags on the worksheet. Okay, and here I can open a parallel with the main driver sheet. On the main driver sheet, when I have a tag configured to read, write, or both, so I have here write or read plus write, we're gonna write only the tag that has changed. Okay, if I change these 3 tags at the same time, I'm gonna send 3 messages to the PLC to write each one of them. Okay, so depending on what you're gonna do, you may wanna create a mix, you know, mix and match. Some tags on the main driver sheets, you don't need to care much about that. Some tags on the standard driver sheets, so when you use the trigger, you go and write all of them at the same time. I use that a lot with recipes. Okay, so I got an interesting question here that some people, they use Kepler to communicate with other HMI. Here's the thing, we have several OPC client interfaces. As you can see, we have OPC DA, we have OPC UA. We were the very first HMI SCADA to have OPC.NET, and we even have XML DA as well. So using Kepware, you can talk both UA and DA, and they even have a beta for .NET. So with other SCADAs, you may not have the option to use drivers. You may have to buy one I/O server that can be an OPC server from Kepware. Using Web Studio, you have the native drivers, but if you want to use Kepware OPC server or any other OPC server, we still have all the interfaces to use them. Okay, so in fact, if I go here and configure an OPC worksheet, that would be a completely different webinar. But here you pick what OPC server you want. So I don't have Kep here. So yes, actually I do have Kepware here. And then I would go here and browse to the OPC items from my Kep server, and here associated with the tags. So it's as simple as configuring a driver, with the difference that on the OPC you must buy the OPC server there, but communication wise the performance is going to be pretty much the same. Okay. All right, so are there any other specific questions? All right, seeing here a question about comparing the communication with other SCADA, like InTouch Suite Link. I cannot compare with InTouch Suite Link, to be quite honest. I really don't know much about that. There's there's really not much that I can compare. What I can compare is with, you know, the things that I know, like most of the OPC servers or anything like that. Okay. That's a good question from Andy, asking, is there a limitation on how many different drivers you can talk to at once? Actually, yes, depending on your target system. So when you're configuring your project, I'm going to stop here. If you go here under project and choose what's going to be your target system, each one of these target systems support a certain number of drivers. If you have the low-end licenses like Lite or Lite Plus, you can have only one driver. That driver can talk to different PLCs, but gonna have only one instance of that driver. Okay, that's the same thing up here. On the standard licenses and local interface license, you can have up to 3 different communication drivers, like we are doing here. Here we have 4 different communication drivers. Okay, so to use 4, I will need to have a license from operator workstation and up, all the way to advanced server, where actually you don't have a limitation of drivers. You can put as many drivers as you want. Okay, and then I got a question here from Gigar. Hi, thanks for being here. So is it faster if we use OPC and driver together? Well, to be quite honest, I'm not. It depends, Jigar. Depends a lot on which driver you're talking about and which OPC server you're talking about. Okay, some of our fastest drivers, we are faster than OPC servers, that's for sure. Our ControlLogix driver, if you talk to arrays, we are as fast as any other OPC server. But some other specific drivers, mainly the serial drivers, we may be slower than the OPC server, that they may know some tricks, they may have some ways to communicate faster. So depending on the communication that you're gonna have, if you are willing to pay for an OPC server, you know, it will be fine. You can still use InduSoft Web Studio and use our OPC interfaces. You see, we have several different of them. We have 4 different OPC interfaces. Okay, so if you want to use both of them together, technically speaking, yes, that's completely possible. Okay, so I got another question here, no, we cannot we don't communicate with InTouch Suite Link. So if you have the Suite Link as the I/O server, No, we don't have an interface for the SweetLink. Okay, we have the interface for the for OPCs. We have interface for DDE, but specifically for InTouch, we do provide a communication driver. So if you have a InTouch application running on one PC and you install what we call our InTouch gateway on that PC, we can talk to all InTouch tags through Ethernet. Okay, so we can send data right to this tag, read from these tags. Okay, talking to the SweetLink specifically, no, but yeah, we can exchange data with InTouch. Okay, welcome. So we approach the 2 hours. We're approaching almost 2 hours here on the call. If you guys have one more question, I have time still for one more question here. What's the maximum number? That's a good question, Bruce. Bruce's question is, what's the maximum number of tags in the main driver sheet? He asked specifically about the MOTCP driver. Actually, the answer is for any driver. On the main driver sheet, you can have currently up to 4,096 tags. Okay, on the main driver sheet. That doesn't mean that that's the max that the driver supports. No, you can have multiple standard driver sheets as well. But on the main driver sheet, right now it works with 40,096 tags. Okay. All right, gentlemen. Let me show you how you can contact InduSoft for more questions that you may have. Here in the United States, you can write to info@indusoft.com. You can call our office here in Austin. Here's our number. We have the office in Brazil. We speak Portuguese, we speak Spanish both here in the US and in Brazil. If you want to speak Spanish, so you can write to this both of these emails. You can call these numbers here. And we have our office in Germany, where we speak both German, we speak English there as well. So you can write there, you can call our German office. Here in the US, we have the toll-free number, the 877 InduSoft. Okay, so if you have any questions about any specific driver or any specific questions in general about driver or about the product, about licenses, please feel free to send us here. We'll be more than happy to answer them, anything related to the product. And follow us on Facebook, follow us on Twitter. It's basically indusoft.com/Twitter. We have also on our website, so if you go to our indusoft.com here, you're always gonna have on the right side down here the latest driver versions. So you can always download the latest driver version. Doesn't matter which Web Studio version you're using. You're gonna download the driver version and install it, and that's gonna work with your Web Studio. Okay, and here also you have on our website our blog, and in our blog we have several case studies and several posts. We are daily updating our blog with information, and here is where also you get to know about the newer drivers that we release, or any newer version of the driver, any new feature that we have on the product, new releases, service packs, patches, hot fixes, everything. We always publish them here in our blog, and also in our Facebook page and in our Twitter page. So subscribe to us, follow us on Twitter, and you're gonna always be up to date with our information. Okay, so again, if you go to our website under About Us, you're gonna find our blog. Okay, and you're gonna have our information this page here. This webinar was specifically about the driver configuration. We're gonna have another webinar on November 23rd with the database connectivity. That's how you're gonna connect to any relational database using redundancy. We're gonna have a full system redundancy on December 28th, and you're gonna keep going throughout 2012 with several of these technical webinars. On the marketing side, we're gonna have the trends and topics now on November 16th. we're going to be talking about packaging SCADA and OEE webinar. Okay, so if you want to see InduSoft being used on a packaging solution or as an overall equipment efficiency, you can attend to this webinar on November 16th. Okay, so we have our trainings here in Austin. Here is a picture of our training facility. Here in Austin, we have all the computers. You're more than welcome to bring yours if you want. We already have in our website the dates for our training for 2012. Okay, so please check our website, read our blog session. There's a lot of useful information there. We have the information when you subscribe to the webinar. So you're gonna send you the link so you can watch again this webinar if you want to. Okay, so thank you guys. I really appreciate you taking your time here. And I wish you all a great afternoon, a great day wherever you are, a nice evening wherever you are. Thanks again, and I look forward to seeing you guys on the next webinars. Okay, thank you very much, you all.